My name is Vinayak and this is a short demo for Byjus Learning Expert. I have been asked to take a short class from my options and I have selected gravitation as the class I want to take. Please note that my explanations shall purely be Newtonian and I will not be dealing with any kinds of Einsteinian gravitational mechanisms. So let's start. Way back in the year 1666, during the plague and all, when Isaac Newton was sitting in his home, he saw an apple fall, much like this pen fall down. And he asked a very simple question. Why do things fall down? Is there something behind the reason of things falling down? And this question, this single question of why things fall down is what led him to gravitation. And that is his greatness. A single question is what answered a huge variety of answers in the field of physics. So let's start with what gravitation is. In his 1687 paper, The Principia, Isaac Newton gives us this definition for the universal law of gravitation. He states that every particle attracts every other particle in the universe with a force Fg that is directly proportional to the product of their masses and inversely proportional to the distance between their centers. Now consider two bodies 1 and 2. They would be having masses m1 and m2. As the law of gravitation suggests, there is a force of attraction between them. Now this force of attraction is proportional to the product of their masses m1 times m2. Also, this force is inversely proportional to the square of the distances between them. If these are their centers, the distance between the centers is given by r, and that goes into the denominator as it's an inverse proportionality. But still, you have this proportionality, which is sort of a hindrance for an equation. So what physicists like to do is to introduce a constant into proportionalities to make them into equalities. So here, we introduce the constant called g, which stands for the universal gravitational constant. Now introducing this beautiful constant, we get the final equation. F is equal to g m1 m2 divided by r squared. This equation, this fundamental equation, is called as the universal law of gravitation. So let me take you into the second part of my demo class. The second part deals on expressing the equation or defining the equation. Well, as I've said before, we have this particular quantity called as g, or the universal gravitational constant. So what is its value? It was a very difficult time in the 1600s to actually measure such intricate values. But much later than Isaac Newton, in the year 1798, a British physicist called Henry Cavendish described a particular experiment which is now famously called as the Cavendish experiment. In this, he used two masses of equal masses of 1 kilogram steel balls and measured the gravitational attraction between them. Knowing this attraction, he was then later able to calculate the value of the universal gravitational constant, which today is at accepted value of 6.647 into 10 raised to minus 11 meter cube kilogram raised to minus 1 seconds raised to minus 1. This is a very small value. If you were to express it as decimals, you would have to have the decimal point followed by 10 zeros before you can write these numbers. That is how small the gravitational constant is. Now going on to the second part of this segment. How did masses or the masses affect the equation or the actual physical phenomenon? First part, I would consider mass m1 to be hugely greater than the mass m2. To give you a physical example, let mass m1 be our Earth, while m2 is some flimsy object like this pen or the apple that Newton saw fall. So what happens in this case is that there is no mutual attraction. Instead, this heavy body tends to attract such small bodies towards its surface. Like our Earth, it holds everything in place. It holds everything to the ground. It will not let anything go beyond a certain height. So if one of the masses is too small, you don't feel like they attract each other. Instead, one particular body dominates this procedure. But what if these were of comparable masses? Again, you cannot have a proper example here on Earth. So let me take you far into outer space. you can have two stars orbiting each other. If they are of equal masses, they both go around each other about a common point. That is, their attraction is equal and opposite. So one attracts the other and no one dominates the other. So such a system can be called a binary system. And finally, let's consider something of our scale. Let the mass m1 be our Earth while m2 be our Sun. I know the Sun is so huge than the Earth, but still the Earth has its own mass. So what happens in such cases is that they form planetary systems. Our solar system has 8 other such planets, which go around our Sun. Our sun being so massive tends to attract all the planets towards itself. Now these planets have a speed of their own. This speed imbibes them to go in an ellipse around the sun. As we've all seen our drawings of the solar system, you have the sun at the center and each planet goes around the sun. What this signifies, or what this law tells us, is that Newton was able to unify laws of man here on earth and the laws of the heavens. For a long time, everybody considered earth separate from the heavens, but Newton, with his path-breaking law of gravitation, was able to unify both. Thank you.